Welcome to Kapadi Maths Classes. Guru Namaha. This is your Murali Krishna. This is the 9th video on single variable calculus of chapter functions. In this video, we are going to discuss about transcendental functions. So the lesson is transcendental functions. Transcendental functions. So which functions are called transcendental functions? Number one is exponential function. Number two, logarithmic function. Number three, trigonometric. And number four, inverse trigonometric functions. There are four types of function under this category. Now let me discuss one by one. Their definition, the domain, graph and range. If any properties are there, that properties also I am going to discuss. Okay, first number one, exponential function. Exponential function. Let f is a function maps domain of f to range of f, defined as f of x is equal to a for x. What is a here? A is strictly positive real number. That means a is more than 0. And one more character for a never be equal to 1. A is not equal to 1. It is called exponential function. So definition is over. Then what is domain? Domain, f of x working rule is a power x. This working rule accepts every real number as input. That means domain of this function is real number set without any restriction. So my domain is a real number set. Now the range. To find range, let us draw the graph for this function. So graph first of all. Now while drawing the graph of the function, you have to take care about the value a. Here, based on the value of a, there are two shapes are there for this function a power x. What are they? Number one case, a is greater than 1 case. Okay, take an example. That a is equal to 2, therefore my function will become 2 power x. Now if you observe carefully, 2 power x, 2 power 0, 2 power 1, 2 square, 2 cube and so on as that. It is 2 power minus 1, 2 power minus 2, 2 power minus 3 as dash. Now when the powers are increasing, that means my x approaching the positive infinity, the values are also increasing. Whereas when x is approaching towards negative infinity, the values are coming down. So this is the main character. Now let me draw some table for this. Okay, how? Let x is equal to, I can take first 0, next to 1, next to 2, next to 3, next to 4, next to 5. I think these 3 values enough. Then I'll go for minus 1, minus 2, minus. Okay, when x is equal to 0, you know very well, anything power 0 is equal to 1, so we'll get to 1. When x is equal to 1, I'll get to 2. When x is equal to 2, I'll get 4. When x is equal to 3, I'll get 8. See, when x values are increasing, my f of x also increasing. Now when x is equal to minus 1, when x is equal to minus 1, I'll get 2 power minus 1 is nothing but 1 by 2. So when x is equal to minus 2, I'll get 1 by 4. When x is equal to minus 3, I'll get 1 by 8. Okay, using these values, let me x-axis, y-axis, their point of intersection origin. When x is equal to 0, my value is 1. When x is equal to 1, and so on. So when x value is approaching the graph infinity, when x value is approaching positive infinity, my graph increases like this. It is just like that. Okay. When x is equal to minus 1, I will get somewhere here. When x is equal to minus 2, here, by here. So when x is approaching negative infinity, my graph is approaching 0. So this is the graph of the function a power x. Of course, it goes to infinity. So this is the a power x, where a is greater than 1. Similarly, case 2, my 0 less than a less than 1. That means a value lies between 0 and 1. So my function, let for example a is equal to 1 by 2 I take, then my function f of x will become 2 power minus x. F of x is equal to 2 power minus x. Now for this also, let me draw the graph values, table values. 0, 1, 2, 3, and this is minus 1, minus 2, minus 3. When 0 as usual 1, this is 1, I will get 1 by 2, 2, I will get 1 by 4, 3, I will get 1 by 8. When we take negative values, negative or negative is positive, so it will become 2, it will become 4, it will become 8. So here, for negative values increasing, for positive values decreasing. Let me plot these points on the graph paper. Okay. So when x equal to 0, as usual 1. When x is equal to 1, it is half. When x is equal to 2, 1 by 4. When x is equal to 3, 1 by 8. So my graph slowly comes to 0. And whereas when x is negative values, it increases. So this is the graph of a power x. So this is a power x when 0 less than a less than 1. Now this is a graph. So graph is over. So if we try to find the range of the function using the graph, if you observe carefully, this both graphs, either case, the graph is not coming down. That means a power x never be negative. Okay, and dead end is almost a 0 in the bottom. And when x approaches either negative side or positive side, my graph is going towards infinity. Therefore, no end in the upwards. That means the end upper bound is nothing but infinity. So by observation of the graph, I got a range as 0 to infinity. 0 also not included. So this is the graph of the function. Please take it. Now the properties. Very simple. Number 1, if a power x is equal to a power y, then x is equal to y. If the base are equal, we can equate the powers. Number 2, if a power x is greater than a power y, don't say always x is greater than y. It depends on x is greater than y if my a is greater than 1. Whereas if a power x is greater than y, then my x will become less than y if a lies between 0 and 1. So these are the properties. Please take it. Under this category, the next function is logarithmic function. Logarithmic function. Let me explain what is this logarithm first of all. Okay, suppose if you have a exponential equation like this, say for example 2 power x is equal to 2. Exponential equation we have to solve. Very easily you can solve x is equal to 1. How? I can write this 2 as 2 power 1. When the base are equal, you can equate the powers. X is equal to 1. Similarly, suppose if you have 3 power x is equal to 9. Now my x is equal to 2. How I got 2 value? Writing this 9 as 3 square. Now when the base are equal, you can equate the powers. Now equating the bases may not possible in all the cases. For example, I have 3 power x is equal to 10. You cannot write 10 as the base of 3. You cannot. So to solve these type of equations, we take help of logarithms. So the logarithms are tools to solve exponential equation. So how do you write it down? Whenever you have 3 power x is equal to 10, 3 power x is equal to 10, or instead of 3 power x, I'll go for a power x is equal to 10. Whenever you have a power x is equal to 10, then this x is called logarithm of m to the base a. Is it okay? So let me write that one. What are the conditions for a and m here? Let me write. Now in the exponential equation, a power x is equal to m. What is a here? A is greater than 0, a is not equal to 1. And whereas m is a positive real number. Why? Because exponential function never generates a negative number. Okay, we have this case. Then x is called logarithm of m to the base. X is called logarithm of m to the base a. Simply we write a power x is equal to m implies or implied by my x is equal to This just symbol log m to the base a. This is very, very important. So I can say this logarithmic function is an inverse function of exponential function. Logarithm function is inverse of exponential function. So based on this observation, we can define the function logarithmic. Okay. Domain of f2, range of f, defined as f of x is equal to log x to the base a, where a is less than 0, a is not equal to 1, is called logarithmic function. First of all, what is domain? Yes, I told you just now, the logarithmic function is just the inverse function of exponential function. Okay, now what is the range of exponential function? A power x is equal to m. This m never be equal to, never be a negative number. Therefore, here x never be a negative number. Therefore, domain of the function is just the positive real numbers 0 to infinity. Then we go to range. Okay. Now what is the domain of exponential function? Domain of exponential function is real number set. Therefore, range of logarithm function is real number set. That means negative infinity to positive infinity. Now we can do the graph also. How the graph goes? Here also we have two graphs based on x value, a value, 0 to x axis, y axis. Now this is the graph of log x base a, when a is more than 1. At the same time, the graph of this is the graph of log x base a when a belongs to 0 to 1. In both cases, you observe the graph distributed between minus infinity to plus infinity. Therefore, my range is equal to minus infinity to plus infinity. Please take it. Next we discuss properties. An important point, if f of x is equal to, we have log x base a. My a value is more than 0 and a is not equal to 1. Now, we have two particular cases about the base a. If a is equal to 10, then that logarithm is called common logarithm. Then this log is called common log. For all the numerical calculations, all the numericals, my base is 10 only. Next one, if a is equal to e, what is e here? E is called Euler number. E is equal to 2.718 approximately. Then this log is called natural logarithm. Natural log. For all base a is equal to 10, that is a commonly used log. When a is a Euler number e, that's called natural logarithm. Now, when a is equal to this case is used for all the numericals, whereas for all theoretical questions, the base is E. Now, in common logarithm, the base is not mentioned, you have to treat it as base as a 10. Whereas in theoretical questions, the base is not mentioned, you have to take A as E, Euler number. Please note these 2 points are very, very important. 1 to any base is always equal to 0. Number 2, log A to same base is always equal to 1. Next one, log A plus log B is log of AB. Log A minus log B is log of A by B. Log A to the power of n is equal to n log A. Log A means B is equal to 1 over log B base A of log A base B is equal to 1 over log B base A. Okay, now proof. Let log A base B is equal to say some m. Remove the log, this implies my A is equal to B power m. Now B power m is equal to A is same as B is equal to A power 1 by m. Therefore we have A power 1 by m is equal to B. Now convert it log, this implies 1 by m is equal to log B base A, or m is equal to 1 over log B base A. What is m here? M is nothing but log A base B. This next property, log A to the power of m base B to the power of n is nothing but m by n log A base B. Proof. Take left hand side, log A to the power of m base B to the power of n. Now I can bring m using this property. So this is m times log A base B to the power of n. Now using the above property, it can be written as m 1 over log B to the power of n base A. Again I can bring n to this multiplication position. So m by n 1 over log B base A. Again convert into original form, I will get m by n log A base B. Therefore log A to the power of m base B to the power of n is m by n log A base B. A to the power of log f of x base A is always equal to f of x. Very simple. If you convert into log, you will get same thing. You will get log f of x base A is equal to log f of x base A. So proof is not required. So A to the power of log of f of x base A is equal to f of x. Next one, we have one more thing. A to the power of log B base m is equal to B to the power of log A base m. That means these two will interchange. It's very simple proof it is. Now proof. A to the power of log B base m. Say for example, we'll go for some p. Therefore we have log B base m is equal to log P base A. So what I do, I write log B by log m is equal to log P by log A. what I do, just I interchange this log b and log a. So this will become log a by log m is equal to log p by log b. Now convert to the single log. We have log a base m is equal to log p base b. Now p is equal to b to the power of log a base m. Both are same. A to the power of log b base m is equal to b to the power of log a base m. Therefore, a to the power of log b base m is equal to b to the power of log a base m. Here technique is very simple, just interchanging these two. This is the important point. Yeah, please take it. Next one, if log a is equal to log a, so same base of course, same base, say for example m, then a is equal to b. Now, second one, if log a base m is say for example b, okay, log b base m. Listen carefully, based on the m value, then my a is greater than b, provided my m is greater than 1. Now same inequality, if log a m is greater than log b base m, then my a will be less than b if my m lies between 0 and 1. Please note that. One more, all you know very well, which is removing log. If log a base b, log a base b is equal to m, this implies a is equal to b power m. The same way, if log a base b is greater than m, then my a is greater than b power m, provided b is greater than 1. Same thing, if log a base b is more than m, then my a is less than b power m, provided my b belongs to 0 to 1. So this is important. When the baseline is more than 1, same inequality carries. If my m value or base lies between 0 and 1, inequality greater than will become less than will become greater than. Please take it.